Alrighty, let's see what we got here. Trig lecture 1022, 1023. The student will determine the quadrant in which an angle of rotation lies when its measure is given to us in radians. So what I'm going to suggest is the thing that I've seen kids be the most comfortable with is to convert your radians to degrees, then sketch out your angle of rotation and determine the quadrant in which it lies. So that's what I'm going to show you, and later on throughout the course of the year I'll show you how to do it in radians, but right now we'll just convert it to degrees, sketch out the angle of rotation, and determine the quadrant in which it lies. So here we go. I'm going to convert this to degrees by multiplying by 180 over pi. And we take a calculator and simplify this. We know that these will cancel. And I'm going to just go 35 times 180 equals divided by 12 and see what that turns into. 35 times, that's not the only way to do it, but it's as good a way as any. I get 525 degrees. So what I've done so far is I've converted this angle given to us in radians. I've converted it to degrees. Now I'm going to sketch out what that would look like in a Cartesian coordinate plane and determine what quadrant it stops in. Here's our XY plane. Here's our origin. Our initial side is the positive x-axis, and we're going to rotate 525 degrees. Well, I know if I go all the way around once, that's 360. And every time I go to another axis, that's another 90 degrees. So I'm just going to start counting. This is 360 plus 90 is 450. If I go another 90, I'll be at 540. So I'm not going to go all the way. I can see that I'll be in quadrant 2. That's a very rough sketch, but what I did was I rotated 360 degrees, added another 90, that took me to 450, and if I went another 90, that would take me to 540, so I stopped shy of 540, which puts me in quadrant 2, okay? So quadrant 2 is my answer. There we are. Let's do another one. This is going to be negative rotation. We change it from radians to degrees. Pretty straightforward. These pi's will cancel one another out. And I will say 11 times 180 divided by 3. 11 times 180 divided by 3. That's 660 degrees, and it's going to be negative rotation. I'm going to do basically the same thing I did here. I'm going to sketch out negative 660 degrees in the Cartesian coordinate plane. There's our Cartesian coordinate plane. Our initial side is the positive x-axis. I'm going to rotate it in a negative direction. I know this is 360 degrees right there. There's 360 rotating in this direction. Now I'm going to count by increments of 90 until I get in the quadrant that will contain negative 660 degrees. So here we go. This is 360, 450, 540 if I add another 90. And 90 plus that is 630. If I go 30 more, I'll be in quadrant 1, if I counted correctly. So this is quadrant 1. And that's what I'm asked for, to identify the quadrant. Don't forget, quadrant 1 is here, this is quadrant 2. quadrant 3, quadrant 4. Okay. And we're asked to identify the quadrant in which the terminal side lies. Oops. So hopefully that makes sense, and hopefully I've done that correctly. Here we go. This is the last one on this lecture. I'm going to convert it to degrees and determine the quadrant in which the terminal side lies. So here we go. My pi's will cancel. 11 times 180 divided by 6. 330. We go to the Cartesian coordinate plane. Y-axis, x-axis, origin. Our initial side is the positive x-axis. And we rotate 330 degrees. Well, that's not quite a full circle, is it? It's going to be 30 degrees shy of a full circle, so it'll be something like that, which would put me in quadrant 4. Remembering that this is quadrant 1, quadrant 2, quadrant 3. The terminal side stops in quadrant 4 in this case, and so that's our answer, quadrant 4. There we go, and that was what we were asked to do. Our objective today is to determine the quadrant in which an angle of rotation lies when its measure is given to us in radians. So one method is to convert the radians to degrees, sketch out the angle of rotation, determine the quadrant in which it stops, and identify that. And that's how you do it. And I hope that makes sense. Best of luck.